if there is a set A and there is a set B, set A, set B. Let us say the elements are 1, 2, 3, 4, 5, and it is said as A, B, C, D, E. Then it is said as the image of one, it is so this is C. Okay, so the function f is defined as from A to B. It is defined likewise. So we have that injection if different elements of A have different images in B. That means 1 and 2, this should not be the this should not get it should get the different images, right? It is like that only. Let us have one more example. This is X, this is Y, this is 1, 2, 3, 4, A, B, C, D, E. So let us say A to 1 and 4 is B, 2 is or 3 is also is B, 2 is C. So this is also a function where we are getting individual image or different image in Y. So how we are getting the different image, that there is a function, what we are getting is this is the input and what you are getting is different output. That means it should not like two output, it should not like this is okay, this is okay, but let us example this is UV, it should not be like this. Here also you are getting answer, here also you are getting answer. So in the particular this pre-image thing or element of U, you are getting two images in V. So it is not one function, it is not one function. The thing is in this particular set you should get different images, whether that is starting from also this is you are getting the same image as B for 3 and 4, that is okay. You are getting B as an image of 4 and 3, also for 3 also you are getting B as an image, but for 2 or 3 these particular things or 3 you are not getting B and C or B and D F, likewise you are not getting more than one image over there. So whatever you are getting is only one image of this element, one image of this element you are getting. That's why it is one function, one element, one image, one element, one image, one element, one image, likewise. So it is known as one function, and also it is known as injection. So we'll move to the next important function, and that is that function is many one function. Number 2, many one function. A function f from A to B is said to be many one function if two or more elements of set A have the same image of or image in B. Let us have one or two examples. This is A, this is B, this is 1 2 3, this is A, B, C, D. So it is here you are having A as image, so 2 over here, 4 as this one, then 5 as also this one, 3 you are getting as here. So in B you have element A, B, C, D, E, and in A you are having 1 2 3 4 and 5 as element, and each and every element you have the image over B, and two or more than two elements of set A have the same image. That means 5 we are having 5 and 4, and these two elements have the same image C. So it is many one. This is many elements have the same image, that is one image. So name indicates. So why I am saying so many times these things is to remember that why it is many one, why it is one. So we'll see one more example, that is X, this is Y. Let us consider 1 2 3 4 5 6 7. Here we will consider A, B, C, D, E, F, G. So it is from here we can see so we can see 1 and 5, this is 1 and 5, we have the same image as A, and we have 4 and 6 as same image as C. So two or more than two elements of set A, that is two elements. Also you can have, if let us say if 8 is there, then also there is a chances that according to this definition we can put one more image to A, or C also we can do. Then two or more than two elements of set A have the same image in B. It is also happening in this situation. That's why I explained this. So one should understand why it is important. We will solve question, then you will come to know. Then the next function is onto function. Onto function. It is also known as surjection, or the words are used in this particular function is surjection, surjectivity, surjective. It is like this. So a function f such that from A to B is said to be, and onto function if every element of B is the functional image or function image of some elements of A, or some or I say f of A equal to B, or we can also say that range of function is codomain. We have seen that codomain, what is codomain and what is range of function. Range of function is codomain of function. Let us have one example for more clarity. This is A, this is B, this is A, B, C, D. Here we have 1, 2, 3, 4, 5. So it can be 1, no, mistake. A can be given as, we'll consider this. B can be given as, we'll consider this. And obviously all the times we need to explain that this is function f, this is function g. Likewise we have to write that also. The function f is mentioned. Let us say this function g is there, function h is there, but it is not 1 1. So why it is not 1 1, I have explained. This is many one function. So this is f, this is g, let us say function. So this is a, b, c, d, 1, 2, 3. Say a goes to, or a is a pre-image and 1 is image. It is possible, yeah. So in B, every element of B is the functional image of some elements of A. So here no other elements are left which don't have the pre-image. That means each and every element of B have the pre-image over here. So there is no any other elements which are not having pre-image. Likewise here also we can see, and this is also we can see, which don't have any pre-image on A, we can see here. So it is not like, we have to understand these things. So function which state that the functional image of B have some elements of A, or it has all the elements of B have the pre-image in A. So we'll solve one more. So